So this lesson is all about the concept known as congruent polygons. And assuming that by now we're familiar with what the term polygon means, we're going to spend most of the time talking about this word, which is congruent. And what we're going to do first is we're going to go over the idea of naming polygons. And once we name polygons, because that is critical to understanding congruent polygons, we're going to build up the steps to finding out whether or not polygons are congruent. Then, of course, at the end, practice it a little bit. So first, as I said, let's review the idea of naming polygons. And to name a polygon, we have to know a few things. First, we have to have a polygon, and B, we have to have named the points. And each of these capital letters here represents a point that is an endpoint of one of the line segments, and also, because it is a polygon, an endpoint of two of the line segments. And so in the pentagon to the left, we have points A, B, C, D, and E. In the hexagon to the right, we have Z, Y, X, W, V, and T. And to name a polygon, any polygon, all you do is you start at one point. For the pentagon, let's start at A. And you move through the sides and name the vertices as you come to them. Now, if we go clockwise around the pentagon, we end up with pentagon A, where we started. Then we hit point B, point C, point D, and point E. If on the hexagon we start with, say, point V, and we move counterclockwise, then we end up with hexagon V, W, X, Y, Z, and T. And so to name any polygon, all we do is choose a vertex or a point to start off with, and we move along the edge of the shape until we get back to the point that we started from. So again, the pentagon to the left could be named A, B, C, D, E if we started at A and went clockwise. It could be named D, C, B, A, E if we started at D and went counterclockwise. Similarly, hexagon Y, X, W, V, T, Z could be named this if we started at Y and went clockwise. Or if we started at T and went counterclockwise, we would have T, V, W, X, Y, Z. So go ahead and pause the video and come up with two new names for each of these polygons, remembering that the polygons are just named by choosing a point, starting at that point, and moving along the edge of the shape until you get back to where you started. Well, there are actually a lot of different names we can name for this polygon. The pentagon itself has 10 different names. We've given 2, and the hexagon has 12 different names. We've given it 2. But I'm not going to go through all of them, but double check that whatever point you started with, you have chosen a direction, either clockwise or counterclockwise, and you have named the vertices as you have come to them. So if you started with W, for example, you would go back and hit W, X, Y, Z, T, V, or if you went the other way, W, V, T, Z, Y, X. And so moving on from the idea of naming polygons, now we get to the idea of congruence. And congruence means something similar to equal. And the concept, to start thinking about it as congruent means basically equal, is a good way of starting with it, but it means something slightly different. So let's go through and see how congruence is used in context. We'll begin to understand why congruence is different than equality. So congruent sides, for example, have equal length. And congruence between these two shapes, we have the shortest side over here with 1 hash mark to show that they are equal length. Those are congruent sides. With 2 hash marks, the slightly longer side in each of them, those are congruent sides. And with 3 hash marks across from what appears to be a right angle, those are equal sides. So those are congruent sides. So for sides, congruence means they have equal length. Now, before we go on, I want you to stop and think. You don't have to pause the video. I'll give you about 10 seconds here. I want you to stop and think, if congruence with sides means that they have an equal length, what does congruence with angles mean? Well, we can't say angles have equal size. We can say angles have equal measure. So congruent angles have equal measures, and this is a notation that we haven't seen before, where if angles are marked with little curved parts of circles here, and if they're marked with the identical same marking, that means they are the same measure. So congruent angles have equal measures. That means the two in the center, the two smallest angles, are congruent. Any 90-degree angles, any right angles, are always congruent with each other. And finally, the two angles at the tops of each of these triangles are equal, so they are congruent. And now, if you've noticed, these same two triangles, we've said that they have congruent angles, and they have congruent sides. Now that is particularly important in this idea. Congruent angles and congruent sides. Now we need to talk about one final concept before we can understand what congruence is, and that is the idea of what are called corresponding parts. And in any shapes that are similar looking or potentially congruent, we have to talk about corresponding parts. That means that they have the same position in the shape. Now, it's very important that this same position in the shape is relative to everything else that happens in the shape. We can't say the same position is the same angle in the lower left-hand corner, because if we look at these two shapes that are above it, the lower left-hand corner is a small acute angle in the case of the right-hand shape, but a larger right angle in the case of the left-hand shape. And in this case, these are not corresponding parts. They are not corresponding angles. When we're looking for corresponding angles, we're looking for things like smallest angles, shortest sides, right angles. To see two right angles is a pretty good indication that they are probably corresponding. And in this case, with the triangles, we have some smallest angles, which are corresponding. Moving up the long side to the top, we have some slightly larger but still acute angles, which are also corresponding. Or finally, in that case, if those two angles are corresponding, then those two 90-degree angles are corresponding. Based on that, we can talk about sides that are between the right angle and the smallest angle. This side is corresponding because they are not the shortest side, but they're the side between the smallest angle and the right angle, and then the two end sides with the purple arrow, and the two longest sides with the blue side there. So again, it's important with corresponding parts that they're not in the same physical position in relation to the paper or into the screen. It is with relation to each other. Right angles are a good thing to look for when you're starting your search for corresponding parts. Smallest angles, shortest sides, things like that. And finally, all of these put together, understanding corresponding parts, congruent angles, and congruent sides. A congruent polygon has the same size and shape as another congruent polygon. They can only be congruent to each other. You need two or more polygons to be congruent because they have to be congruent to each other. That is, if they have the same size and the same shape, that is, their corresponding parts, their angles, their sides, have equal length or equal angle measure. Again, we said these two right angles were corresponding. Those two angles have equal measure. The two smallest angles, as we said before, have equal measure. The two middle angles have equal measure. And now if we look at the sides between the two smallest angles, we have these three red dashes, which means they're equal. Between the right angle and the smallest angle, we have two dashes, which means they're equal. And between the right angle and the larger acute angle, we have one dash, which means they're equal. So even though this shape is flipped, we can still see that they have congruent sides. And so how we're going to show that these polygons are congruent is that we are going to flip the right-hand polygon so that you can see that it actually is identical to the one on the left. And so now we get to the point where we named polygons before. We have to name congruent polygons now. And so when you do that, you list their corresponding vertices in the same order. Now in this case, if we're going to name these polygons here, and we're going to name these two triangles that are congruent, we can't just haphazardly say ABC is the same as EFD, because that wouldn't be true. If we start at one particular angle in a triangle and we move around the triangle and we say that these are congruent, we have to move in the same order. So if we start with A, the larger angle, and say ABC is the name of this triangle, the corresponding congruent triangle starts at the same angle, D, and goes down through the angles and sides in the same way, D, E, F. What we can't do, though, is start at A, move A, B, C around the small angle, and we can't start at D and say then D, F, E, because D, F, E starts at the green larger angle and then goes to the right angle, which is not the direction that this first one goes. So it's very important when you name them that you name them in the exact same order. So go ahead and practice this and see if you can name these two congruent polygons. Just the congruent polygons. Start at any vertex you want at the first one. Name this, in this case, trapezoid and generic quadrilateral on the right, and see if you can name the vertices in the exact same order. That is, not necessarily in the same orientation, clockwise, counterclockwise, but moving in the same direction around the shape so that those two shapes are congruent. Well, I'm going to start here and say that you, for the trapezoid, and for example, say you named A, B, C, D. In which case, I started at a large angle, moved down a short side, across the longest side, and back up to D. So in order to do that, I have to start at the short parallel side in the other polygon, say side G, move down the side, along the longest side, and back up to the short parallel side. So ABCD is congruent to GHEF. Use that concept to check your own if you gave a different name. And then for the second one on the right, if I say that this is WXYZ, I have to start at the top of the longest, side above the right angle, move down to what seems to be a right angle, and around the shape in the same direction. That is VSTU. Again, if you gave a different shape name, that is fine. Go ahead and check to make sure that you have moved in the same direction around corresponding parts. If you started at one angle next to the right angle and then you moved towards it, you must move towards it in your other polygon, and the same thing for away. So go ahead now and see if you can name the corresponding parts, that is the corresponding angles and the corresponding sides to these polygons. So the corresponding angles on the trapezoids, we can say that this A is corresponding to, for example, F. You could say corresponding to G, but then we'd have to change the direction of the shape. D then is corresponding to the other angle on this short parallel side, which is G. And now that we've got A, D in that order, H is corresponding to C and E to B, which we can see here. A to F, B to E, C to H, D to G. And that means the sides between A and B have to be corresponding to the sides that relate to that on this polygon. A to B, F to E. B to C, E to H. C to D, H to G, and D to A, G to F. The same thing is true on the quadrilaterals on the other side. X it looks to be a right angle, so S, the other one that looks to be a right angle, has to be corresponding. Moving up from there, because it seems that these are just mirror flipped from left to right. W and V have to be corresponding. Y and T, because they're on the bottom along the edge from the right angle, and Z and U must be corresponding because they're across from the right angle here. And that means between W and X and V and S, again, between the same vertices are corresponding sides, X, Y, and ST, etc., YZ, TU, and ZW, UV. So finally, all that we're interested in now at the end, try it now with these two triangles on your own to see what you can do with these. See if you can find the congruent shapes the corresponding parts and solve for the unknown values, angle B and angle F. Well, the congruent shapes, if we said ABC, for the first triangle, we would have to move in the same direction around the second triangle, DEF. Again, because these triangles are oriented the same way, we can move the same way around them. But just make sure whatever angle you start with, you are moving towards the same angle in the other polygon when you name them. And so the corresponding parts and the answers to the problems are here for you to look at. A and D as right angles are corresponding parts. B and E as the next largest angle are corresponding parts. And C and F as the smallest angle are corresponding parts. And so the sides between them, AB and DE, BC and EF, and AC and DF. So finally, angle B has to be 60 degrees because angle E and angle B are the same, and angle F has to be 30 degrees because angle C and angle F are the same because they are corresponding parts in congruent polygons.